Hello tech stalkers and welcome back to a new video. Today's video will be a math video, and today's video will be solving parametric equations. The name sounds fancy, but trust me, it's so simple and you can master it in just one lesson. Before diving into the subject, I have two systems of equations here. I wanted you to recall some skills in math, some basic skills, which are substitution and solving for a certain variable. So we will start off with the system on the left. As you can see, x is set to 4 and we want to find out the value of y. So we will plug in x in this equation. As you can see, we have x and we just have to substitute for the value of x. So in this case, y equals 3. What is an x? It's a 4. So we put the 4 instead of the x and plus 1. Nothing changes, just the x becomes a 4 because it is equal to, the first equation already told you, or the first expression already told you that x is a 4. Anyway, we substitute and then we find the value of y. So 3 into 4 is 12 plus 1, that's 13. Great. Now let's move on to the system on the right. As you can see, it's not straightforward. We have 5x equals to 1. In order for us to substitute for the value of x in the second equation, we must find what x is equal to, not what 5x are equal to. Okay, so as you can see, 5 is multiplied with the x. So what we'll do is we will divide both sides by 5 and 5 here. This goes with this, and 1 is divided by 5. So we have x equal to 1 over 5. Now we will plug that in our equation. Yeah, so y now becomes y 5, 1 over 5 plus 2. And we will just solve or simplify. So 5 goes with 5, 1 plus 2 is 3. Simple, right? Now let's dive into the parametric equation part. Okay, that's huge. Alright, so as you can see, what's different in these two systems is we don't have 2 variables, we have 3 variables, and this is the only difference. In this problem, we will not be finding a value, we will be finding what, the equation, what y is equal to in terms of x, y, yeah, in terms of x. So so in order to do that, as you can see, y is written in terms of t, right? So we have y is equal to t squared minus 2, and y is equal to 5t, right? So you might say at the first look, we don't have the value of t, but we do have it. As you can see, the top equation tells us that x equals to minus 3t. We might rearrange this equation to find the value of t and then plug it in the y equation. So let's see. So minus 3 is multiplied with t. What we will do is we will divide both sides by minus 3. or -3. So this and this cancelled, and we're left with t is equal to x over -3. Now let's write it in a more tidy way. T equals x over -3. So now that we got the value of t, so let's put this in a box. This is the value of t. So now let's plug it in this equation. I'll rewrite this because the t squared is not as clear, but as you can see, t squared minus 2. Now we will substitute this in like this t here. So this is the value of t that will be substituted here. Alright, so let's see. Y is equal to, instead of the t, I will put a bracket to put this value of t here. So we have x over -3, and then 2 or 2 and -2. Alright, so we can simplify this further by squaring the terms inside the brackets. So we have x squared and -3 squared will be 9. And then the -2 doesn't change. So this is the final result. Easy, right? Now take a minute to look at the solution. Alright, now please pause the video here and try this one yourself. Alright, so now that you have paused the video and did the problem, let's do it together. Okay, so again, this equation tells us the value of x in terms of t, right? We want to rearrange the equation to find the value of t. So let me write this. It's hard to type this on this board because the square is always, like, the power is always misleading because it cannot be written as a power up. So I'm sorry for that. I'll rewrite it here. So this equation tells us x equals t squared minus 2. Now let's start solving for t. First of all, we will move this to the other side. Always move the the terms that are constants before multiplying or dividing or doing like any square roots. So now we have t squared is equal to x. So this is supposed to be plus 2, gone, and plus 2 here. So x plus 2. X plus 2. Now to remove the square, the power of 2 from both sides of the equation, we do a square root. So this goes with this, and Now we have the value of t as square root x plus 2. Great. Now we will plug in, this is the value of t, we will plug the value of t into the y equation. So y equals 5t, so our t is square root x plus 2. Simple, right? Alright, so now that we've looked at parametric equations with t, let's look at a slightly different type of parametric equations. So we have a famous trig identity that says cosine squared theta plus sine squared theta is equal to 1. And mostly, or in our case, you just have to memorize it like that. Explanation here is kind of like pointless because it's not related, like the lesson is not related to trigonometry that much, so just remember it like that, memorize it or by heart it. Cosine squared theta plus sine squared theta is equal to 1. Alright, so here what they want us to do is to treat sine and cosine as if they were variables. So imagine the sine as cosine theta as a whole piece, okay? Imagine as if it was t, or imagine as if it is any other letter, okay? So it is one piece that travels together. And actually, so these are two separate sets of equation. So treat every cosine theta and sine theta as a one piece, okay? So we want to find the value of cosine theta. In this type of parametric equations, you always want to find the value of cosine theta. You want to solve for cosine theta like we solved for t, and you want to solve for the sine theta like we solved for t. It's like solving for a letter. So let's start off by the cosine theta. We have x is equal to 2 cosine theta. Now the cosine is a one piece, as I said, and it is multiplied by 2. So what will I do is I will divide both sides by 2. Divide by 2, done, and divide by 2. Oh, okay, so now we have cosine theta is equal to x over 2. Great. Alright, how about the sine? Let me use a different color. Alright, so sine theta, okay, for sine theta is equal to y, right? That's what this here is saying. Okay, can you guess what are we going to do? Take a second. Yes, exactly. Like we do in normal equations, we're going to divide by 4 because the sine theta is multiplied by 4. So we will divide by 4 on both sides. This is gone. And we're just left with sine theta is equal to y over 4, right? Okay, so let me remove all of this. Let's get to the part where it gets interesting. So now we found the value of sine theta and we found the value of cosine theta, but we still need an equation that relates x and y, right? Well, we will use this trig identity to do that. What we will do is simply, as I said, you must memorize this because you will use it in every application of parametric equations. If you encounter a question that includes cosine theta or sine theta. So we have this equation, cosine squared theta plus sine squared theta is equal to 1. Alright, so we're going to substitute the value or plug in the value of cosine theta, which is x over 2, in this identity, right? So we will change this cosine. So this becomes x over 2 squared theta. Let me write this in black so you can spot what has changed. So cosine squared theta plus, other thing that will change is this sign here. What is sine theta? Yes, as you guessed, sine theta is y over 4, and that's what we're going to substitute in this equation. So y over 4 in brackets, and the identity continues normally. Okay? Alright, so you can simplify this more. And actually, we're going to get to a pretty interesting point if we did so. So let me remove this line out here. Okay. So let's square, okay, what's in the bracket. We have x squared over 2 squared is 4 plus y squared, 4 squared is 16 equals 1. This equation looks familiar. This form of equation looks familiar. Let's think back about conic sections. Alright, if we took this equation to Desmos, which is actually a website that I recommend you using in math, this is our equation, and if we were to plot it on the graph, it is an ellipse. So this is an equation of an ellipse that has its center in the origin. That's why we don't have a H or a K at the top. So that was it for the example that I offered. Here is another example that is a homework for you, so go ahead, try it out, and write the answer in the comment section down below. And if you found this video useful, don't forget to give it a thumbs up, subscribe to my channel for more videos, and see you in the next video.